This is ECE23 performance task number 6. I am Francis Andesca from BSECE 3B. Today I will be reporting about how to determine the transition table, state machine diagram, and trellis diagram from a convolutional coder. So what are convolutional codes? These are a type of error-correcting code that generate parity symbols via the sliding application of a Boolean polynomial function to a data stream. So first, the transition table. It is a tabular representation of the transition function. So here we have our convolutional code, and here we have our transition table. For the input of 0 with an MO of 0 and an M negative 1 of 0, the output for N1 is 0, N2 is also 0, and N3 is also 0. The next state of MO should be 0, as well as M negative 1 will also be 0. For an input state of 1, and the current state of MO being 0, and also 0 for M negative 1, the output for N1 will be 1, for N2 0, for N3 1, and for the next state, MO will be 1, and M negative 1 will be 0. For an input state of 0, and a current state of 0 for MO and 1 for M negative 1, the N1 output is going to be 1. The same with N2 and N3, they will all be 1. And for the next state, both will be 0. For an input state of 1, the current state of 0 for M0, and for M negative 1 being 1, the output for N1 will be 0, 1 for N2, and 0 for N3. The next state of M0 will be 1, and the next state of M negative 1 will be 0. If the input is 0, and the current state for MO are 1, and M negative 1 is 0, input of N1, the output of N1 will be 1, N2 will also be 1, and N3 will be 0. The next state for M0 will be 0, and for M negative 1 will be 1. For an input of 1, and the current state of M0 being 1, and M negative 1 being 0, the output for N1 will be 0. For N2 it will be 1, and also 1 for N3. And for the next state, both M0 and M negative 1 will be both 1. For an input of 0, and the current state of both M0 and M negative 1 being 1, the output of N1 and N2 will be 0, N3 will be 1. For the next state, M0 will be 0, and M negative 1 will be 1. For an input of 1, and the current state of both being 1, N1 will be 0, N2 will also be 0, and N3 will be 1. For the next state, M0 will be 0, and M negative 1 will be 1. Oh wait, for N1 it will be 1, for N2 and N3 it will be 0, and for the next state, both M0 and M negative 1 will be 1. A state machine diagram. It is used to describe state-dependent behavior for an object. Based off the chart in the last slide, here we have the state diagram. For 0, 0, and also 0, 0, it will be 0 over 0, 0. And for 0, 0 to 1, 0, it will be 1 over 1, 0, 1. From 1, 0 to 1, 1, it will be 0 over 0, 1, 1. For 1, 1 going to 1, 1, it will be 1 over 1, 0, 0. And from 1, 1 to 0, 1, it will be 0 over 0, 0, 1. Meanwhile, from 0, 1 to 0, 0, it will be 0 over 1, 1, 1. And from 0, 1 till 1, 0, it will be 1 over 0, 1, 0. And from 1, 0 to 0, 1, it will be 0 over 1, 1, 0. For the trellis diagram, it will plot all possible states versus time. So basing on on this diagram, we will make our child's diagram. So from 0, 0 to itself, it is 0 over 0, as the same here. And for 0, 0 to 1, 0, it is 1 over 101 here. For 0, 1 to 0, 0, it is 0 over 111, as can be seen here. And for 0, 1 to 1, 0, it is 1 over 0, 1, 0, as can be seen here. And for 1, 0 till 0, 1, it will be 0 over 110, as can be seen here too. So both of these. And then 10 till 11 is 0 over 011, also the same here. And for 11 to 01, it will be 0 over 001, which is also here. And for 11 to itself, it will be 1 over 100, as with here. That is the end of the presentation.